Hello everyone, in this video we will be talking about the basic concept of operational security. In particular, we'll be talking about firewalls and IDS, but please note that we're not going to talk about the details on how to configure firewalls and IDS. Alright, so let's start with the firewalls. In principle, firewall isolates organizations or the internal network from the rest of the internet or public internet networks. Okay, so it works in both ways, incoming and outgoing. So it can block or allows an incoming packet or outgoing packet. So well, in general, firewall is located, or this is the very basic let's say purpose of the firewall. It is located at the gateway of the router gateway. It separates between the public internet and the internal networks. Alright, so now why we need the firewalls? So first of all, firewall can prevent DOS attacks or denial of service, and there are many types of DOS attack. One of the attack is called SYN flooding. So SYN flooding, if you remember the three-way TCP handshake, it is started by a client sending SYN packet, and then to respond to this SYN packet from client, the server will send another SYN packet from the server and the ACK with the ACK. So it's piggyback. The ACK is piggybacked by the SYN packet from the server. And then in the last part, the client will send ACK in response to the SYN packet that is sent from the server. But then with the SYN flooding, the attacker will not send the last ACK packet to the server. So basically, the TCP connection will not be the real TCP. There is no real TCP connection because the last ACK packet is not being sent from the client. So if this is going on over and over, the server will have no resource left for the real TCP connections. Okay, so it can also prevent illegal modification or access to internal data. So basically, this is just the results of this of the attack from outside networks or external networks. Yeah, I mean, for example, the attacker can replace any home page with something else. Basically, this is types of deface attack. Okay, this attack is not that damaging. If for example, if someone can gain access to the database, then it can be more damaging than just replacing the web page. Okay, it can also allow only authorized access to inside networks. For example, we can set authentication to users or the host. And then there are three types of firewalls. Well, basically there can be more. It depends on how we look at or how we categorize the types of the firewalls. But then in this lecture, we'll limit this into three types. First of all, the very basic one is stateless packet filtering, and then we can also add stateful packet filtering. We can add more correlation with the different packets. And then there's also something called application gateways, or in practice we may know or be familiar with the terms proxy. Okay, so we start with the stateless packet filtering. So basically, stateless packet filtering, this is the most basic types of firewall, and usually it is located at the router firewall or the gateway router. Stateless packet filtering only checks the header of the packet. So it's each of the packet by packet. So it cannot make any correlation with different packets. All right. So it only, for example, it can only make a decision whether to forward or to drop the packet based on source and destination IP address, or TCP UDP source and destination port, or maybe ICMP message type, or TCP SYN and ACK bits. But then this type of firewall cannot, let's say, make correlation with different, series of packets. Okay, so these are some examples of firewall configuration. We can block incoming and outgoing datagrams with IP protocol field equals to 17. So this means that the higher layer protocol above network layer or IP is UDP. So basically, you want to block any incoming and outgoing packet which is using UDP protocol. Or also either source and destination port is 23. So basically we want to block any incoming or outgoing telnet session. Okay, so any incoming, outgoing telnet session and UDP session are blocked. Okay, now the second example, we block the inbound TCP segments with ACK equals to 0. So what it means? So basically, it prevents external clients from making TCP connection with internal clients. Okay, but allows internal clients to connect to outside. So this ACK equals to 0, inbound segments, TCP segments with ACK equals to 0, it means that it is actually the source is coming from outside. And then we expect that at the end, after receiving the request from the outside network, the internal the host in the internal network can send ACK to the outgoing to the external network. Okay. So for the first case, in the second case, when internal clients connect to the outside, then the host in the outside network can send back the ACK. Okay, so the ACK bit equals to 1. Okay, so that's why it is allowed. Okay, the internal clients can connect to the outside, can initiate a TCP connection. But then for the external clients, when it wants to connect to any host in the internal networks, it is not allowed. Okay, so for example, let's say we have a server in the internal network. So you don't want to allow any external host to access the server inside our networks. Okay, so some more examples of stateless packet filtering. Let's say we have this policy, no outside access. So how we set the firewall is to drop all outgoing packets to any IP address with port 80. So the IP address can be set as like stars. We want to reject or deny all incoming TCP connections except those for Intrusion public web server. So basically, we can the default configuration is to deny all TCP SYN packets except for this one. This is the IP address of the server, Intrusion web server, and port 80. And also, if you want to prevent any web radius from eating up the available bandwidth, we can drop all incoming UDP packets except DNS and all router broadcasts. So basically, UDP packets there are many types of UDP packets. So for example, we can also even set up peer-to-peer data transfer with the UDP, and we only allows for example DNS, because DNS is also using UDP. Well, we can also prevent the network being used for smurf DOS attacks. So we can configure the firewall to drop all ICMP packets that is going to broadcast address. So for example, like this our network's broadcast address. And then lastly, we can also prevent your network to being trace routed. So we can drop all the outgoing ICMP with the detail expired. So you may experience this issue when you try to trace route any web server. The trace route may reach the gateway, the router gateway of the, let's say for example, you want to trace route the tick.com or any institution web server. It may reach the gateway, but then when it reaches to the destination of the our trace route, we cannot get the replies until the timeouts, right? So basically, the trace route packet from our side reach the destination server, but then the firewall does not allow, or it denies the outgoing packet, the response of the trace route. Why? Because the internal network administrator doesn't want any external people to get the let's say the topology, internal network's topology. Excuse me. Okay, so basically, to configure the firewall, we create kind of access control list, or ACL. So basically, it is rows in the form of tables. For example, like in this example, it applies top to bottom. So for example, we by default we deny all connections except what we allows in top, or the previous rows. So in this case, for example, we allows only outgoing DNS requests and incoming DNS response, and we also allows any outgoing TCP requests from internal networks, and the outgoing HTTP requests from the internal clients, and the HTTP response from the external web servers to the internal clients. Otherwise, every other connection is denied. All right, now we'll look into the stateful packet filtering. So if we take a look back into the stateless packet filtering, there is some limitation or a drawback from the stateless packet filtering. For example, it can still admit the packets that makes no sense. Okay, so for example, if there is any packet that it is not destination, it should be source. Okay, according to this example, source port of 80, and it has ACK bit, it will be allowed for the if we are using only the stateless packet filtering. But then this packet may not necessarily have the active TCP connection. So it means that, for example, like there is no TCP connections being created for this particular let's say source and destination ports, but then somehow we still receive this kind of packet. So basically this is illegal. I mean, it comes from any illegal let's say source. All right, so but then if we use the stateful packet filtering, it can track the status of every TCP connections. It can make correlation. So for example, it can track from the connection setup from the SYN until the FIN. I mean, from the three-way handshake until closing the TCP connection. So if, let's say for example, we the network received any packet from external networks, but then there was no actual TCP connection set up for that particular packet, then we can deny this packet. Or for example, there was any actual TCP connections, but then it was already closed, but then we still receive the packet from that connection, we can also block that kind of packet. So we only receive the make sense packet. And also we can also create timeout for inactive connections at the firewall. So for example, for the case of SYN flooding, so normally the client with the SYN flooding, the client is not going to send ACK. Okay, so this TCP connection is kind of hanging, so the server cannot really let's say allocate resources for the TCP connection, because the TCP connection is not established until the server receives the last ACK bits from the client. But then if we set the timeout, let's say if the server does not receive any ACK from the client until the timeout is reached, then we can block block the packets. Okay, so now the difference with the stateless packet filtering, we can add one more let's say column. We can check the connection. So for example, in this case, in this if there is any cross mark in the check connection, we need to check the connection. For example, like we are not going to check the connection from the internal network to the outside networks, but then the incoming network, we need to check the connection, whether the packet is making sense or not. Like for example, like if there is if this particular TCP connection for the HTTP service is already closed, then we are not going to admit any incoming packet. Okay. The same with this UDP. Okay, if there was no UDP request for this particular response, then we are not going to admit this packet. Alright, now we're going to the third types of firewall, application gateway. So basically, this is quite similar. I mean, we may be familiar with the terms proxy. So this is how it is actually. This is what it is. So basically, okay, let's take a look directly to the example. Let's say we are using a gateway application with gateway for telnet service. So if any host wants to perform telnet, okay, to the outside host, all the telnet users have to go through the gateway first, okay, and then the gateway will check whether the host is authorized to perform telnet to the outside networks. If the host is authorized, then the gateway will establish telnet connections to the outside, let's say outside host. And then after this, the second part of this, the router will only filter the router only allows telnet stations that is originated from the gateway. I mean, any other telnet stations not originating from the application gateway will not be allowed by the router filter. Okay, so in a similar way, we can also apply this to the web proxy. Okay, so any incoming or outgoing chain, it has to go through the application gateway or proxy, web proxy first. Okay, so now we will review some limitations of firewalls, including the gateways, application gateways. It cannot, first of all, it cannot detect any IP spoofing, because, for example, whether we use the stateless or stateful firewalls, the router cannot know if the data really comes from the claim source. I mean, from the because it only checks the destination and source IP address. Okay, but then we cannot know whether this IP address written in the packet is the real IP address. Alright, so if you're talking about the application gateway, if let's say we have multiple applications, then we need to have different gateways or different types of proxy for different applications. So this is not really efficient. And then client-server software must know how to contact the gateway. So for example, if you're using a web browser, we have to set the proxy in our web browsers. And then actually there is one more types of firewall, which is I guess you are quite familiar with that. It is application firewall. It is sitting in the application side. So for example, the famous one is called web application firewalls. It may be an extension of the web server, or it may be a separate application itself. So so for example, it's very close to the application, your web applications. So it is really located at the close to the server itself. So but then when it is web application firewall, then it is really to filter any attacks related to the web application. So for example, like it may be cross-site scripting attack, or SQL or broken authentication, and so on and so forth. Alright, so that's just one another types of firewalls that we are not discussing in this slides. Yeah, again, so going back to the limitation of firewalls, there is also, if we are talking about the UDP connections, normally the configuration is whether to all or nothing policy for UDP. So for example, whether we just block all UDP connections, in this case we'll block the let's say DNS sessions to the outside networks, or if we want to allow the DNS, then we can also, then we have to allow all the UDP connections. Then yeah, we are open to all types of attacks from the outside networks. So at the end, there is this kind of trade-off. So the trade-off is between the degree of communication with the outside world and the level of security. So if we want to have high level of security, of course we have to limit the degree of communication with outside network. But then if you want to be more flexible with the communication with the outside network, then we have to reduce the level of security. So this is that is why still some sites suffers from the attacks, okay, if you're only relying on the firewalls. Okay, now we will briefly talk about the IDS or intrusion detection systems. Okay, so if reviewing back to the packet filtering firewall, it only operates on the headers, okay, TCP/IP headers only. It cannot really going into the content of the packet itself or the payloads, okay. And okay, specifically for the packet filtering stateless, there is no correlation among the stations, or even with the stateful, it only correlates among different packets, okay. But then different stations, it cannot really make it correlations. With the IDS, okay, IDS is, let's say, it is more there's more intelligence. But then IDS itself, if we are talking about the IDS, it only serves for the detection mechanism. It cannot really prevent the attacks from happening. Okay, so it can at the most it can give alarm if there is if it detects any intrusion. But then the actual prevention is coming from the firewall. So normally it comes together, the firewall and IDS. Well, right now there is also called the intrusion prevention system. So apart from detecting any intrusion, it can also prevent the intrusion to happen in the internal networks. But anyway, let's just talk about the IDS. It performs some so-called the packet inspection, so it can look into the content of the packets. It's not only checking the headers, but it can also going inside the packet itself, the content of the packets. Of course, like it will take longer time to analyze the content of the packets, but then we can really see whether there is any malicious code inside. So we can for example, we can analyze if there is any virus or malware attacks from outside networks. And then it can also correlate the packets among different stations. For example, the attackers may perform port scanning to see which are the available ports or open ports in the networks or in a specific host, so that the attacker can use that as the entry to launch the attacks. Or if there is any network mapping attempts from the external attacker, because if the attacker knows the topology of the internet networks, then they can do a lot of things to our internet networks. And also those attacks sometimes we have to correlate the DOS attacks. It's not just because DOS attack normally it comes with many packets coming to attack the specific servers. Okay, now with respect to the locations of the IDS, it can be located in different places in the networks. First of all, there is in principle there are two types of IDS. There is network IDS, so basically it is a node or a sensor located in the network side, and there is also host IDS, so it is located at the host side or the server side. So we can install IDS in different parts of the network. So for example, we can have one in the DMZ or demilitarized zone. So this DMZ is located after the firewall and after the IDS. Okay, so the IDS is this DMZ is specifically for for servers that should be connected that have direct connection to the outside public internet. Okay, but then for the internet networks, we have to apply another firewall. Normally we have another firewall here, and then we can have IDS specific for the traffic in the internet networks. Alright, so I think that's it for the operational security, and this is the end of the security chapter. We discussed some basic techniques in security, from the cryptography, for encryption, decryption, using symmetric and public key cryptography. And then we also see how we can apply the public cryptography for the message integrity to ensure the integrity of a message. And then we also talk a bit about the authentication at the endpoint, network endpoints. And then we see how the principles of the cryptography can be applied to secure the email, or basically this is not just email, it can be any message, any information. And then the SSL, this is using combination of the public and symmetric public key cryptography and symmetric cryptography. IPsec at the network layer, and then the link layer we use we review some techniques used in the Wi-Fi or IEEE 802.11. And finally, we talk about the operational security, in particular on the firewalls and IDS. So I think that's it for this chapter, network security. I hope you enjoyed the video, and we'll see you again in the next chapter. So see you again, and bye.